is John for Year 12 Physics, and this is the last lesson on mechanics and on momentum and energy. And this lesson is on springs. So, springs can be stretched or compressed. So, when you stretch a spring, you make it bigger. When you compress it, it becomes smaller. And how can we do it? We can apply a force in order to either stretch a spring or compress a spring. The amount by which a spring stretches or compresses is called its extension. So if that's your original length and that's where it's stretched to, this distance is your extension. According to Hooke's law, for a spring, the force is proportional to its extension. So that means when you have a greater force, you will have a greater stretch. And so force is proportional to extension, and the formula and the constant of proportionality, which is the gradient of this graph, is called the spring constant. And there's a negative sign to say that when you take this weight of the spring, then the spring is going to go back to its original position. So it's going to move back in the opposite direction. When you stretch it, you're pulling it down, but when you release the force, it's going to go back up. So this negative sign is just to say it goes back in the opposite direction. Okay, and the spring constant indicates the stretchiness of a spring. Stiff springs have got high spring constant, and stretchy springs have a low spring constant. Now, when you compress a spring or stretch a spring, it actually stores energy, and this energy is elastic potential energy that is stored in the spring. And how do you find that elastic potential energy? So it's actually the area under a force extension graph, and because this is the area of a triangle, it will be half F times x. Now, because F is equal to kx, you can also write this formula as half kx squared. So this is the lesson, the concepts behind the spring, and there are some questions on the spring that I have worked out. So remember, in order to find the spring constant, your length has to be in meters, and your mass, it has to be actually the force. So you got to go mass times g in order to get the force, in order to get that. So okay, so here we go. So here is your mass on a spring, so mg. So you first find the force and then force divided by extension, and you get that. And then there's one more over here. And that's it.